This is Transformational Pediatrics, and I'm Dr. Mike. And with me today is Dr. Isabel Tifo and Dr. Emily Faro from Children's Mercy. Today, we'll explore faster answers, brighter futures, how Children's Mercy is transforming genetic diagnosis. Dr. Tifo, I wanted to start with you. What inspired Children's Mercy to pioneer the use of what is, I think, known as 5-base sequencing in a clinical setting versus the traditional genetic testing method?
Thank you for having us. So the technology of I-Fi, it's basically like using the same kind of sequencing technology, but using longer pieces of DNA. I like to explain to my mom, it's like doing a puzzle with bigger piece. It seems to be easier, but it's just more efficient in terms of looking at the different type of variation than using smaller pieces, which can be in a puzzle, like placed in different area. So the bigger the pieces, it's easier like to align it to what we call the blueprint. And also the 5-base is actually that we can look at the methylation. So it's another markers that we can use for different type of variation in the genome.
So traditional genetic testing has, we have the 4 bases, right? But the number 5 here, that 5th one is representing epigenetics, or what we refer to methylation. Is that correct?
That is correct.
What does that mean to a general practitioner, a general pediatrician? What does having that 5th element really do or help you when it comes to genetic diagnosis?
So this methylation, it's like if you have like a switch that turn on and off. So this little marker, as we call epigenetics, it's what decide if the gene's going to be expressed, so on, or the gene's going to be not active. So it helps us. There are some disease that actually it's only this little mark that is important for the diagnosis, but because traditional testing, we're looking at just tiny pieces of this information. Now we have it on the global genome. So we have a lot to learn about it.
Dr. Faro, there was a study, I believe, that showed a 10% increase in diagnostic success. Can you share a story or an example that illustrates the real world impact of this advancement on a patient or family?
Yes, of course. And that's been one of the exciting things about moving to a more comprehensive test, such as the 5-base clinical long-read sequencing. And so by taking multiple tests and condensing them into a single efficient test, what we've seen in multiple patients, in particular, one family comes to mind, and that infant was born with a muscle disorder, and they ordered just one single test to check for a few different muscle disorders and got a diagnosis. But what the clinicians noticed with this family is that this particular child had additional features that had never been associated with this muscle disorder. And so that family actually then received long read sequencing with us, and we found that there is actually a dual diagnosis. So they had 2 diagnoses, and together we were able to explain the complete phenotype for that patient and for the family that we had seen. And so had we run Hi-Fi first, we would have had both answers in a much shorter time frame than it took, as you can imagine, to order one test, have it come back, wait for that test to come back, have the clinicians decide that wasn't the full answer, and then come back again.
Obviously, speed is critical, right, in pediatric care. Dr. Tifo, based on what Dr. Faro just said, how do you believe this has reduced that time to diagnosis for pediatric patients?
It's significant. We're talking about changing diagnosis within a couple of days versus like months and months. Some of the genetic testing that we do traditionally, the return to the result can take 3 to 6 months. So having one test that do all, it's giving the answer faster for the family, but also helping the physician to decide what additional imaging needs to be done if needed, and also which other subspecialty clinic needs to be involved for deciding the best care for the patient.
I think this next question is for both of you. I wonder if it would be helpful for the listening audience if you both could just run through what really happens during genetic testing from, the first time you see the patient to when you actually have your results.
Sure, that's a great question. And it can be a difficult process. So, say we have a new baby in the NICU and they're born and present with different phenotype or different features. The first step that happens is that a clinician, usually a geneticist, will evaluate them and look and see, do these features align with the syndrome that I recognize? Now, it turns out, particularly in infants, that's very difficult because we don't have the full phenotypic expression of that syndrome or disorder. And so then we have to decide what test should we order. And the other thing that we're learning with genomics is that there's actually really complex underpinnings for molecular disease or genetic disease, and that it takes currently with traditional testing multiple assays for us to evaluate all of the different ways that we can have a genetic disorder. So, what might take 5 different tests in a traditional setting, we can really condense down to really one test of long read first. And we can look at methylation, we can look at copy number variants, we can look at single nucleotide variants. We can also look at expansion disorders where sometimes the genome takes a triplet repeat, so repeats 3 bases and repeats it thousands of times. We can look at all of that with one test first, and then we can come back and say, yes, we have an answer. No, we don't, but we're concerned about one particular one that really requires a specialty test, which is rare. And what our study showed is that when you did long read first, we actually had a significant decrease in the number of follow up tests that we needed to order afterwards.
Yeah, it's so much more complicated, isn't it? I think a lot of, especially older physicians like myself, it's okay. I'm older than you guys, no worries there. Genetic testing really wasn't even a thing back when I was in medical school and a resident. But now, when you hear about it, I think a lot of physicians, pediatricians included, they just think that you guys are just looking for that one mutated gene or something. But it's so much more than that, right?
It is. And we've been truly building on our research capability, meaning that we've tried things in the past because newer technology tend to be more expensive than traditional one upfront. So at the beginning, we were sequencing with this newer technology and we were trying, oh, let's do it a little bit less coverage just to reduce the cost or do things just to reduce the cost. And then we realized like years after, we should have done it right better at first so we don't have to resequence the patient because when you do it right, with this new technology, you will not need to resequence the patient. What you will need to do is actually apply the other like bioinformatic tools that are being developed and constantly getting better every week, every month. So we can truly like keep looking at the genome of the patient for the feature that they have today, but that can be in long term for their cancer risk, their pharmacogenomic profile for treatment decision and fertility and so on. There's so much more to the genome than just finding an answer for the current phenotype of the patient when we get the DNA first.
So both of you have now mentioned that this more innovative, this 5 base sequencing often replaces multiple rounds of testing that you might have to do in traditional, right? So obviously that's impacted speed to diagnosis, but what about some of the other things like the emotional aspect for families, the financial aspect for families? How has it reshaped those things?
So I think we're just getting started, but what I think is really exciting is that when you offer a comprehensive test first, or when we're able to do that, then we don't have to keep going back to the family. So things that we've seen in the past is we'll order one test and it's negative, then we will try a second test, and then we get what we've started calling in the lab genetics fatigue because you have very real concerns and you have a child with medical concerns that you need to address. And so when genetics keeps asking to try again, it gets exhausting. And so, from a family perspective, knowing that we're going to do the best test that is out there, we believe, first, lets them know, yes, I have a diagnosis, or the answer is still sometimes is no, we don't have a diagnosis, but knowing right now that we've looked at all the things and we're going to pause and then we'll maybe come back and revisit later. I think it just takes things off of their plate and helps drive to an answer one way or the other much quicker.
Dr. Tifo, how many medical centers like Children's Mercy are doing this kind of innovative genetic testing?
As of today, we are the only center in the US and even in the world using this technology as a clinical test. Some place in the US, they're using it for research, but we are, as of today, and it's been more than 2 years, the only one. So we are very, very lucky, and our population and our physician are very grateful that we can do that. But we don't want to be the only one. We hope that many people are going to follow the same path that we've been doing. And we've been also doing international collaboration and national collaboration to give access to other families to this technology because we believe it's a better test.
Dr. Farrow, the study that showed how fast you're able to get to a diagnosis versus traditional also hinted at some future discoveries in non coding regions of the genome. Can you explain that and what potential breakthroughs you think might come from that?
So, when we think of the genome today and when we put our clinical hats on and what we can report, we're really limited to the known coding genes within our genome. So, if the genome is 3 billion base pairs, so 6 billion nucleotides if we're in pairs, and we have maybe 20,000 genes, that's only 3 to 5% of the whole genome. So, that means we're still learning what the other 95% of the genome is doing. And so by doing the long read sequencing, by getting a more complete picture, we know that we're banking information for the future. And so on the research side, what we continually do is that, especially through Genomic Answers for Kids, is that we're developing new research algorithms or new pipelines that allow us to test and see, well, what else can we pull from the genome that might be helpful in diagnostics? And after we've done our research work, we can then see and evaluate, well, what would be appropriate to move into the clinic. And so when we think about long read sequencing today, again, it's just the tip of the iceberg on what we're reporting. We know that there's more information in that 95% that we need to learn about, and that's globally in genomics, not just at Children's Mercy, of course, and more algorithms that we can apply so that we can start to push our diagnostic rate even higher.
So, when it comes to the non coding regions, what are your thoughts? Are these regions more regulatory? They're playing a role because it's a significant part of the genome, right?
Exactly. So we think regulatory is a good first step to look at. And even in some of those regions with genes where we know the regulatory regions are defined, it still can be difficult for us to determine what the changes mean. Looking at those methylation signatures. And so, in order to report those back clinically, you have to establish your normal signature. But that means you have to find enough people who have a change to show what's different from your normal. And so, as we gather more cases and research, and look, we can start to say, well, this is the pattern we expect if the gene is behaving normally. And this is the pattern we expect if the gene has been turned down and that's causing the phenotype.
Dr. Farrell, I'll stick with you with this question. Children's Mercy's Genomic Answers for Kids, GA4K, that's a program that I was told has already delivered over 2,100 diagnoses. How does that program fit in to the type of genetic testing and research you're specifically looking at?
Genomic Answers for Kids is a sustained translational research program that's really transformed genetics and genomics for us, and that we're enrolling children and their families with a suspected genetic component to their disease and looking to see how can we drive diagnostics for them. And so by standing on that research foundation, that's where we're able in the research world to test the new technology, to take risk with the new long read sequencing. When in a clinical lab, you're not able to take those same risks because you can only offer validated stringent testing. And so having this translational research program that really works hand in hand with our clinical team is how we've validated all of our clinical testing. Starting with short read genomes, we just celebrated 10 years at Children's Mercy for short read genomes being offered clinically. And again, we were the first in 2015 to offer short read genomes for pediatrics. And that's how we've moved into long read sequencing. So we're really, again, very grateful and fortunate to have a program like Genomic Answers for Kids that lets us really look into genetics and genomics for our patient population and how can we use this technology and this information to better help our patients.
So here's the big question, and this is for both of you, and then we'll start with Dr. Tifo. When you look at all the advances being made in genetic diagnoses, what are you most excited about when you look into the future about genetic research and diagnosis?
We are every day excited because our field moves so fast. I used to say every Christmas we get a new sequencer or a new machine to push the limit of our research program. I'm really excited. You were talking about the non-coding, but I'm also really excited about bringing more functional, because what we see rare, we need functional. We need the RNA, which is like the basic of how we express the gene and bring the protein and then the pathways. So the RNA for me, it's really exciting to add on all those, what we call the omic together. And we have also like many other people within our research institute that do animal models, cellular model, but also like bringing truly like better understanding of what we see in the genome of our patient. So yeah, the omic thing and the new technology is how we build our program. We always at the cutting edge of the technology.
Dr. Farrow?
I echo what Isabel said, but what's really exciting, I think, for all of us as well, is that as testing becomes more efficient, as it becomes more affordable, we're expanding who we can offer this testing to. So that is true within our own community, that we see a dramatic difference in who's able to get genetic testing, who's comfortable ordering genetic testing within Kansas City, within our region. But again, if we look nationally, we're developing a reputation for our collaboration and helping, and again, bringing diagnoses to people who otherwise couldn't have gotten one. And I think it's really exciting to see how your work is helping more and more people.
I got to tell you, this is fantastic information. I know there is so much more that we could go into, and I'd love to have you guys back and maybe dive into some more of the nuance and specifics of it. But great job today. Thank you so much for coming on the show.
Thank you for having us again.
For more information, go to childrensmercy.org/research. If you enjoyed this podcast, please share it on your social channels and check out the entire podcast library for topics of interest to you. This is Transformational Pediatrics. I'm Dr. Mike. Thanks for listening.